Stanford University.
Okay, well, welcome then to lecture 10, yes, 10 of CS193P, fall of 2013-14 academic year. And today we are going to talk about multi-threading. Okay, we're only going to talk about it briefly, but because you'll learn a lot from multi-threading kind of through experience. Then we're going to talk about UI scroll view, a very important view that allows you to expand what you can see on that little phone screen to let you look at larger things. I'll do a demo that's going to cover both of those things, multi-threaded and scrolling. And then, however much time we'll have left, we'll get started on our next topic, which is UI table view. We'll continue that on Wednesday. So multi-threading. Okay. The idea with multi-threading is that you want to divide up the execution paths of your program into different and distinct paths that are possibly running at the same time. Now, I say possibly. From your standpoint as a programmer, they look like they're all running at the same time. But of course, if you have a computer or a phone that only has one processor, there's no way for them to run at the same time. But the OS makes it appear that they are by basically time slicing, giving each one of them a little bit of time to make it seem like they're all running at the same time, okay? And so if you did have a multiprocessor, maybe they would actually be running at the same time, or maybe not, but you don't care and you don't know, okay? Totally not for you to know. Why do we want this kind of behavior where we have these multiple threads of execution? Well, a couple of reasons. One, we've got one thread of execution, which is that main thread of execution where the user is interacting, doing touch events. We want that thing to be very responsive. We want that to always be listening. We never want that to not be listening. The other thing is we have other threads of execution that actually might block. Okay, why would they block? Why would they stop? Well, let's say they do a network call and they're waiting for something to come back over the network. Well, they have to wait for that thing to come back. So they are blocked, they're stopped. Okay, we would never want that main execution that's listening for touch events to be stopped, okay, or blocked, right? But these other ones, it's okay if they block. If they're waiting for something, they're waiting for something, okay? So to understand how we do multi-threading in iOS, there's one thing you have to understand, and that's queues. Okay? A queue, just like a queue in the real world, queue means like a line, like you go to the movie theater and there's a line of people, that's called a queue, for those of you who don't know that word. And so you got that queue, and the same thing is happening here with iOS multi-threading. You have these queues, but in these queues, instead of people waiting for the theater, there are blocks. Blocks in the way we talked about last week, you know, the curly brace thing, okay? So you got this queue in line, you have these blocks, and they're all waiting in line to be executed. And depending on which queue they're in, when it's their turn, when they get to the front of the line, they get taken off the queue and they get to run, okay? Possibly in a separate thread, okay? Usually there might be multiple threads assigned to one queue or single thread. Again, you don't know what's going on. All you know is you're putting these blocks in a queue and they're being taken off and allowed to run. And people can be allowed to come off the queue one at a time. So at the movie theater, one person gets to go and watch the whole movie, and when they're done, the next person goes in. Okay? That's called a serial queue. That's what the queues we're going to talk about are. It's a very simple queue. There's also concurrent queues, however, where a whole bunch of people get and go into the theater, and they all get to be doing stuff simultaneously. Okay, it's a little more complicated because you got this queue, you're pulling off these blocks and they're all running it together. If they ever want to share resources or something, they need a little more advanced multi-threaded program. But we're going to do the simple kind where one person coming out of the queue, one block coming out of the queue at the same time. Okay, so that's really what you understand, is that's how this multi-threading works. Queues of blocks. Okay, now there's a very important queue, which is the main queue. That's the queue on which multi-touch is happening and all the UI stuff is happening. And this is special for two reasons, all right? One is that we never want to block it, okay? So we never want to do anything that's going to take very long on that main queue. And the second thing is we use it for synchronization for everything that is UI related, okay? So all the methods, not all, but most of the methods in UIKit, you want to call them only on the main queue. And in fact, if you called them on some block that came off of some other queue, probably wouldn't work. Now there's a few, like UI image, UI font, UI color, a couple of those things, they'll work off the main queue. But anything that is going to cause the screen to have to change or synchronize or anything like that, or that might cause that, That all needs to happen on the main queue. So we use that main queue both to have something that's constantly responsive to the user and for synchronization to keep everything in sync with what's going on in the UI side. Everything else we could do in other queues. And actually, it's amazingly, iOS is doing things like actually drawing in another queue. Okay, you don't know that. You don't know what queue it is. You don't see it. But it's actually doing another queue. Why? Because if it's drawing something very graphics intensive and the user multi-touches in the main queue, you want to switch back to that main queue and give it the priority. And the drawing can wait a little bit while that multi-touch gets done. Okay? So this main queue doesn't want to be blocked. It's where we do the synchronization. And I'm going to show you how you can write code that is running on other queues but needs to do UI. Because that's a problem, right? If you've got a block that's on another queue, non-main thread queue, non-main queue, then and you want to do some UI, you got to somehow talk to that main queue. You got to put a block basically on that main queue. There are other queues. Mostly they're created by iOS behind the scenes. I'm going to show you an example here in the slides of a queue that is visible to you in the API and how we deal with that. All right, so how do you execute a block on another queue? Okay, this is a C-level API. This is a very low-level API below objects. So you're not going to see any object stuff in this lowest level API. There is an object-oriented layer on top of it called NS operation and NS operation queue, but it's kind of a thin object-oriented layer. This is the core layer. And this is the fundamental method, fundamental C function, dispatch underbar async. And that means asynchronously put this block on this queue. Okay, so you see I've declared a queue there, local variable queue. It's of type dispatch qt, which is a type def. And I'll talk about how to get a queue in a second. And then you just say dispatch async, the queue you want to put the block on, and then the block. And the block takes no arguments and it returns no values. It's just a block. And you put any code you want in there. And that block will take its place in line on that queue. And when that queue gets around to it, it will take it off. One thing, by the way, about the main queue, it never takes anything out of its queue to run until it's quiet, meaning whatever current touch events have been processed. Okay, it's not going to, right in the middle of a touch event, take something off its queue and go do something, right? So the main queue waits till it's a little quieter, and then it'll take things off the queue and run it. So you can always post things on the main queue and be sure that it's not going to interrupt the user in any way. All right, so how do we get a queue to do this dispatch async with? Well, let's talk about the main queue first, because that's the most important queue that we need to dispatch things. And the way you do that is dispatch underbar get underbar main underbar queue. That will return the main queue to you, and then you can call dispatch async with a block on that. At the higher level, that NS operation queue level, you can do NS operation main queue as a class method. It'll return an NS operation queue object, which represents the main queue. Again, it's just a thin object-oriented layer pretty much on this C layer. And we'll see where that comes into the API. What if you wanted to create another queue? Let's say you're going to do some big math calculation or some big image processing calculation. You don't want to block the main queue, the main thread, so you can create another queue. Very simple. You just say dispatch underbar queue underbar create. And the first argument to that function is the name of the queue, and that's like going to show up in the debugger and stuff, so this is kind of an internal name. Notice that's not an NS string, because this is a low-level API. This is about the only non-NS string you're ever going to see in this class, because this is the lowest levels we'll go. It's a const char star, and here I'm just using the name. Okay, you just want to give it a name so you can recognize this queue when you see it in the debugger or something like that. And then the second argument is whether it's a serial queue or a concurrent queue, right? So null means it's a serial queue. And so that's the kind of queue we're going to talk about. Again, so one person comes out of the line at a time. And there's kind of an easy mode for dispatching back to the main queue, which is perform selector on main thread. It's an NS object method. You can send it to any NS object, and you just pass a selector and its argument, the with object argument. It could be nil, and then it has no arguments. That's fine. And the wait until done is whether you're going to wait until this thing gets pulled off the main queue and run on the main queue and then finishes before this thread that's calling this goes or not. Usually wait until done, we would say no, we don't need to wait. We're going to call this method on the main queue, and whenever it executes is when it executes. So this perform selector on main thread is just like saying dispatch async onto the main queue, a block that just calls that method. Okay? That's all it really is. But it's just kind of easy mode. It looks nice. It's, you know, you don't have to do the dispatch async business. But you got to be able to have one method to call. You put all the stuff you want to do in one method. So let's look at an example that uses this, okay? This is more understandable, probably much more by example. So this example is I want to download the contents of a URL from somewhere on the internet. So I have a URL, http / something or other, and I want to download that from the internet. Well, I might be on cellular, I might even be out of network range right now. That could take a very long time. It could take minutes. Okay, well clearly I don't want my user interface, for example, to be blocked waiting for the network to give me that URL back. Okay, so I have to basically call this, do this download, network download in a different queue, in a different thread, not the main queue. Okay, so there's an API in iOS for doing exactly this. You give it a URL and it will go do it in a different thread. Now, when it's done though, it needs to call you back and tell you, hey, I got that URL. And the way it does that is kind of cool. It downloads the URL to a local file, and then it calls you back and gives you a URL to the local file. So now it's all local. And so now you can open up the file and do all you want, and it's not going to be blocking because the network is not a part of it anymore. It's downloaded the contents of the URL. Okay, so here's how that works. First, we create a URL request. A URL request is just a wrapper on a URL. You can see I created there request with URL, NSURL, object, URL with string, some URL. Okay, so that's how we create a URL request. A URL request is a little more than a URL because you can specify some other things about that request, things you want to do. But most of the time, we just create it just like this, and we don't do anything else to the request. So now we have a request, a URL request. And I apologize in advance for URL. I have trouble saying that. I'm going to be saying that 100 times in the next few slides. Then we have this configuration thing. Don't worry about that for now. And then we create what's called a URL session. So a URL session is an object that manages a session of time that goes out and talks to the internet and gets the answer and all that stuff. So the session is the main thing that's doing here. And we're going to talk about how we create that, because how we create the NSURL session determines where, what thread, which queue our code is going to be executed on. And so now we have a session, and we can ask the session, please create us a task which downloads that URL. And very simple, download task with request. You give it the URL request, and then you give it a completion handler. Now that completion handler, very important to understand. You can see that it's a block, right? The arguments to that block, the first argument is the most important argument. That's the URL of the local file that it put the URL into for you. So it downloaded this URL off the internet and put it in a local file, and now it's giving you a file URL, not an HTTP / URL, but a file : URL, right? URL that points to a local file. And then the other arguments about errors and responses, don't worry about those. But the main thing is you got this local file. And then inside this block, okay, what if you wanted to do UI things here? Okay, well, if this block is being executed on the main queue, you're good to go. But if it's being executed on some other queue, any other queue, you're not good to go. You're going to have to talk back to the main queue. So let's look at those two examples. First of all, let's look at creating the session using this method, session with configuration. Again, don't worry about the configuration. Delegate : nil, delegate queue : some queue. Okay, so this NSURL session thing, it has a delegate. Remember delegates, we're just getting used to delegates now, hopefully you are. Remember the dynamic animator delegate that we set, and it told us when all the animation stopped, and then we blew up the blocks. Okay, so we just set a delegate of the animator to be the controller, and the controller implemented a method. Same thing here. You can set yourself as a delegate to this URL session, and as it's doing all its downloading, it'll give you updates. Oh, I loaded it 5,000 bytes. I just loaded some more bytes. Oh, I've got the file now. Okay, I'm putting it into